Right now in Antarctica, some of the world's most influential countries are investing billions to expand their presence on the coldest, most remote continent on Earth. Not for tourism or simple scientific curiosity, but to secure access to resources hidden beneath miles of ice. Resources so vast and strategically important that they could reshape global power dynamics in the coming decades. China recently inaugurated its 5th research station there, with a 6th already in development. Russia continues conducting extensive surveys in surrounding waters, often without full public details. Meanwhile, an international agreement that has protected Antarctica for over 6 decades is approaching a critical review point in 2048. What exactly lies beneath the ice? Why is it drawing such intense interest? And why are major powers racing to strengthen their positions before that deadline arrives? If you're drawn to stories that explore the planet's biggest unanswered questions, give this a like and subscribe. We dive into these topics regularly, and you won't want to miss future episodes. To grasp what's truly at stake, we need to look beneath the surface. What we find there may completely shift how you view the southernmost continent. Most people picture Antarctica as an empty, frozen wilderness at the bottom of the map. A place with no permanent residents, extreme conditions, and little practical value. But that view misses how enormous and resource-rich it actually is. Antarctica ranks as the 5th largest continent, larger than the combined area of the United States and Mexico. It holds about 70% of Earth's fresh water, locked in an ice sheet thick enough to bury entire mountain ranges. In places, that ice reaches nearly 5 kilometers deep. Surface temperatures can plunge below 90 degrees Celsius, cold enough to freeze exposed skin seconds. Winds sometimes exceed 300 kilometers per hour. During winter, some regions experience months of total darkness. Yet life persists in surprising ways, from surface wildlife to microorganisms thriving in isolated environments deep below the ice, in waters untouched by sunlight or air for millions of years. Chinese research teams have focused heavily on these extreme habitats, and their findings tie directly into broader strategic interests. The ice sheet is so massive that it has literally depressed parts of the continent's bedrock, deep into the Earth's crust. In West Antarctica, some areas sit more than 2 kilometers below sea level, not due to ocean flooding, but from the sheer weight pressing down. Remove that ice, and the land would gradually rebound over thousands of years. But the real story isn't just the visible ice or measurable rock. It's what has accumulated layer by layer inside that ice over more than 1 million years. A priceless historical archive. A frozen library of Earth's past. China's polar researchers didn't arrive simply to plant flags. They came seeking data locked inside the ice itself, information unavailable anywhere else. Each year's snowfall adds another layer that compresses over time, trapping tiny air bubbles like time capsules. These bubbles preserve samples of the atmosphere exactly as it existed when the snow fell. Scientists extract long ice cores from deep drilling. The deeper the sample, the older the air. The oldest continuous core recovered dates back about 1.2 million years. By analyzing these, researchers can study ancient carbon dioxide and methane levels, volcanic events, and temperature patterns from eras long before humans existed. This is how we learned that during the time of woolly mammoths, atmospheric CO2 was roughly half today's levels, or that the Sahara was once lush and green. China has pushed ice core research further than most, gathering insights into past climates and carbon cycles. These records inform large-scale modeling used for understanding resource formation over geological time. Rising global temperatures threaten this archive. If significant melting occurs, that unique historical record could be lost forever. Whoever accesses and studies the most of it gains a substantial edge. Hidden heat beneath the ice. While the surface appears lifeless and still, deeper layers tell a different story. Parts of West Antarctica sit above dozens of active volcanoes. The immense pressure from the ice prevents normal eruptions, but the heat slowly melts the ice base from below, creating hidden pockets of water and steam in total darkness. This geothermal activity helps explain why some ice sheets are retreating faster than early models predicted. Warming from above was only part of the equation. One volcano, Mount Erebus, emerges near the coast as the southernmost active volcano on Earth. Its heat carves warm caves into the surrounding ice, where scientists have found unique mosses, algae, and previously unknown DNA sequences. In 1979, Air New Zealand Flight 901 crashed into its slopes, with wreckage and remains still preserved in the ice today. Antarctica preserves everything it touches, from ancient air to recent human history. This subsurface heat also drives another remarkable system directly relevant to why major powers are increasing their focus here. Rivers flowing in total darkness. More than a kilometer beneath the surface, where rock meets ice, water moves constantly. A vast network of subglacial lakes and rivers flows through the bedrock in complete darkness under enormous pressure. Some lakes are massive. Lake Vostok stretches 240 kilometers long and 50 kilometers wide, larger than Belgium, and has remained sealed for 15 to 25 million years. Nearly 700 such lakes have been identified, some linked by underground channels. When pressure builds in one, sudden floods can release billions of liters through the bedrock, causing the ice sheet above to rise and fall by several meters, detectable by satellites. Human contact with this hidden world remains minimal. China has invested in advanced electromagnetic surveying to map these systems without widespread drilling, revealing where water flows, heat concentrates, and mineral-rich zones may exist. The continent hidden from view. Remove the ice in digital models like BedMap 2, and Antarctica reveals a dramatically different landscape. Buried mountain ranges, such as the Gamburtsev Mountains, rise thousands of meters, with no human having ever stood on them. Denman Canyon plunges deeper than the Grand Canyon. Ancient river valleys and fossil evidence show Antarctica was once a warm, forested land connected to other continents in the supercontinent Gondwana. A massive circular feature in East Antarctica, roughly 300 kilometers wide, creates a strong gravitational anomaly. It may mark one of Earth's largest ancient impact craters or a major geological formation. These features matter because Antarctica shares geological history with South America, Africa, India, and Australia, all rich in coal, oil, iron, copper, gold, and rare earth minerals essential for modern technology, batteries, and renewable energy systems. China already dominates much of global rare earth production and processing. Detailed geological knowledge of Antarctica could provide enormous strategic advantages when rules potentially change. The 2048 deadline. The 1959 Antarctic Treaty established the continent as a zone for peace and science, freezing territorial claims and banning military activity. A 1991 protocol specifically prohibits mining. However, the environmental protocol includes a review clause starting in 2048. Any party can request reconsideration of the mining ban, and if approved, resource activities could become legal. 22 years may seem distant, but establishing year-round infrastructure in Antarctica takes decades. Continuous scientific presence builds influence in future negotiations. China's stations are strategically placed for broad coverage. Russia conducts seismic surveys in potentially resource-rich areas tied to its historical claims. The United States maintains a significant presence, but faces aging infrastructure challenges. Presence matters under international law. Countries investing now will hold stronger positions when 2048 arrives. The treaty itself doesn't expire, but its key protections face potential challenge. What's really at risk? Beyond resources, Antarctica's ice cores provide our only million-year climate record. Losing them to melting or disruption would erase irreplaceable knowledge. Subglacial lakes like Vostok contain ancient ecosystems offering insights into possible life on other worlds, such as Jupiter's moon Europa. The nutrient flows from beneath the ice support the Southern Ocean food web, sustaining everything from krill to recovering blue whale populations. Industrial activity could disrupt these delicate systems with long-lasting consequences. Sea level rise from Antarctic ice melt remains a serious global threat. The treaty has succeeded because cooperation benefited everyone. Whether that spirit holds through 2048 will shape the future of this unique continent. Antarctica remains one of the few places still functioning largely because it has stayed untouched. The race is already underway, quietly but steadily. The decisions being shaped today will determine whether this frozen frontier stays a shared scientific preserve or becomes something else entirely. If this shifted your view of Antarctica, drop a like and subscribe. Enable notifications to stay updated. What do you think? When 2048 arrives and pressure grows to open Antarctica for resource development, will the treaty protections hold, or will long-term presence decide the outcome? Share your thoughts in the comments. I read them all.